Hello friends, today we're going to talk about graphing absolute value equations. First, let's look at the parent function. That means there's nothing being added or subtracted anywhere. There's no number in front of the x. So we're plugging in these numbers into the absolute value of x. So really we're just finding the absolute value of each of those numbers. Absolute value of -3 is 3. Absolute value of -2 is 2. Absolute value of -1 is 1, and then 0, 1, 2, 3. If I graph these, we have -3, 3, -2, 2, -1, 1, 0, 0, 1, 1, 2, 2, 3, 3. So I can go ahead and graph this. It is a graph, which means, or it is a function, which means it's going to go on forever here. So we'll make sure to put our arrows. Notice that there is a line of symmetry. If we go through the vertex, whatever's happening on the left side of the vertex is also happening on the right side of the vertex. What I mean by that, if we look at our line of symmetry, we go 1 to the right and 1 to the left to get our point. We go 2 to the right and 2 to the left, 3 to the right, 3 to the left, and it would keep going. 4 to the right, 4 to the left. So we do have symmetry there, which is important because then we can just find the points on one side of the line of symmetry and then match them on the other side of the line of symmetry. The other thing to notice here is the slope of this line. If you recall what slope means, it's how we get kind of from one point to the next. So to get from any point to the next point, we go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Same here, up 1 over 1, up 1 over 1. So that's going to be important. All right, let's pull up Desmos here for these next ones. I'm going to do a split screen. We're going to graph each of these equations in Desmos. I was hoping I had it saved, but I don't. That's okay. All right. So we have y equals the absolute value of x plus 5, and y equals, let's just look at the absolute value of x here. So our absolute value of x is our original equation, the blue one there. The red one is when we're adding 5. So notice that it moved up. Our vertex was at 0, 0, and then it moved up to 0, 5. If we did plus 1, our new vertex is at 0, 1. So when you add a number after the absolute value portion, the graph translates up. Let's look at if we subtract a number. So again, our blue is our original. They want us to look at the absolute value of x, take away 3. If we notice that, our original vertex was at 0, 0. Our new vertex is now at 0, -3. What if we did subtract 6? Now our new vertex is at 0, -6. So when you subtract a number after the absolute value, it moves down. Let's look at what happens when we add or subtract a number inside the absolute value. So let's add 5 inside the absolute value. Again, our original one was 0, 0. Our new one now is -5, 0. So I added 5 inside the absolute value and it moved left 5 spaces. Let's see when I add 1 inside the absolute value. Again, our original equation had a vertex at 0, 0. Our new one now has a vertex at negative 1, 0. So this one also moved left 1 space. So when we add a number inside, it moves left. Let's see what happens when we subtract a number inside. X take away 4. Now our vertex is at positive 4, comma 0. So it moved to the right. Let's see if that is still true when we subtract 2. Yep, now it's at 2, comma 0. So it moves right. I should tell you if it moves up, that means it's positive. Moves down, it's negative. Moves left, it's negative. Moves right, it's positive. What if we put a negative in front? Well, let's see here. We'll change this to negative. So the red one, the blue is our original, the red is the negative. Notice that it opens down when there's a negative in front. So it's going to be an upside down V if there's a negative in front. And what about if we put a number in front? So let's see here. Again, the red is our original. And we're going to have it be 2 times X. Or sorry, the blue is our original. The red is the new one. So notice that it got kind of skinnier, right? Or narrower. So if there's a number other than 1 in front of the absolute value portion, the graph changes. It either gets narrower or wider. And that's because of the slope. We talked when we graphed this, we said it had a slope of 1. So if there's a number in front, that means the slope is going to change, which is going to change whether the graph is narrower or wider than the original. Let's graph some. We need to decide. Also, sorry, let me back up. We talked about H makes it go left or right, right? Whatever's happening inside makes it go left or right. K makes it go up or down. So if we have X minus H plus K, we're going to have a positive H and a positive K. If we have X plus H plus K, we're going to have a negative H and a positive K for our vertex. If we have X minus H minus K, we'll have a positive H and a negative K. And then finally, X plus H minus K gives us a negative H and a negative K. You did learn about this stuff with quadratics, so it should be ringing some sort of familiar bell. Let's look at some examples. First thing we always want to do is find our vertex. I know subtracting inside is going to make it move right 1. Subtracting on the outside is going to make it move down 2. So our vertex then is positive 1, negative 2. So I go positive 1, negative 2. There's no number out in front here, which means my slope is just 1. I'm going to draw in my line of symmetry to help me. So from here, I just go over 1, up 1, over 1, up 1, over 1, up 1. And then we can do the same thing on the other side of the line of symmetry. And this is our graph. Let's look at one that does not, or that has a number out in front. Adding on the inside is going to make us go left. Subtracting on the outside is going to make us go down. So if I go left, that's -1. Down is -4. So I'm going to put my vertex there and draw in my line of symmetry. This one, though, has a slope of 2. So this means to get to each next point, I'm going to go up 2 over 1. So up 2 over 1, up 2 over 1, up 2 over 1. I'm just going to keep going all the way through my graph. And then you can do the same thing on the other side. And then go ahead and connect them. Let's look at another one. -3 times x minus 4. This is like +0. Subtracting inside makes it go right. This one, I guess you can say it goes up 0 or down 0. It doesn't matter because it's 0. So the vertex for this one is +4, 0. Now, this negative is going to make my graph be upside down. And then 3, because it's negative, we're going to go down 3 over 1. So from my vertex, I'm going to go down 3 and over 1. Let me draw in my line of symmetry first. So down 1, 2, 3 over 1. 1, 2, 3 over 1. And I can do that on both sides, or I can just use my line of symmetry. So this one, since we're going down, it's going to make our graph turn upside down. And again, I went down 3 over 1. Down 3 more over 1. Let's look at writing the equation. First thing we always want to do is find the vertex. So for this one, my vertex is located right here at -3, -2. So it's moving left 3 and down 2, which means my vertex in this case, let me write down -3, -2. So when I write my equation, y equals, I'm going to leave a little space. Since it's negative, or I'm sorry, it's moving to the left. So we know that if it moves to the left, that means we're actually adding in the parentheses. So x plus 3. Again, moving left means we're going to be adding in our final answer, or in our original equation, down 2. This graph is upside down, so I know it's going to be a negative in front, but let's count how far it is between. To get from one point to the next, I go down 1 over 1, down 1 over 1, down 1 over 1. So that's just -1. So my final answer, -1 times x plus 3, take away 2. Of course, you can always graph that on Desmos to make sure you get the same picture that I got. Let's try another one. First, we'll find the vertex. My vertex here is at 0, 2. 0, you're not moving left or right at all. You have a couple different options for this one. You could write x plus 0 or x minus 0 plus 2. That's one option. Or you could just put the absolute value of x plus 2. Either one of those works. They mean the same thing. But we're not done. We have to figure out what the number in front is. So to get from one point to the next, I need to go up 2 over 1. Up 2 over 1. So that means my final answer is y equals 2 times the absolute value of x plus 2. Another way to think about this, here, my a is -1, again, because I'm going down 1 over 1. My h is -3. My k is -2. So plugging all that into this equation, if that makes it easier for you, y equals a times the absolute value of x minus h plus k, which if we simplified this then, -1 x plus 3 minus 2. These two mean the same thing, okay? For this other one, we said a is 2, h in this case is 0, k is 2. So plugging it into the original equation, 2 times x minus 0 plus 2, which is the same as 2 times the absolute value of x plus 2. So look at the last one. My vertex is at 4, -2. So I know my h is 4, my k is -2. Let's find my a. To get from one point to the next, I need to go down 1, 2, 3 over 1. And I'm going down 3, which means my k is -3. Also, because it's upside down, I know that it's negative. So putting it into the equation, y equals -3, x minus the h value, which is 4, plus the k value. So you could leave it like that, or -3 times x minus 4 minus 2. So again, you have to find the vertex and you have to find the value of a. Once you find the vertex and value of a, again, the vertex is at h comma k. Just plug it in to this original function and then simplify.